In this skill, we're going to be looking at the properties of alpha, beta, and gamma radiation. So I've made a little table here to go over the key ideas. So firstly, our symbols for each of these, alpha, beta, and gamma. We've got an alpha symbol, that's that kind of fish shape for alpha particles. We've got that B with the little tail, that's our beta symbol. And then we've got that gamma kind of ribbon symbol for gamma. Now, an alpha particle is made up of 2 protons and 2 neutrons. So essentially, it's a helium nucleus. A beta particle is just an electron. And gamma, that is a high-speed electromagnetic wave. So you can see our high-speed electromagnetic wave, that's a wave that has no mass. An electron, that has very little mass. A helium nucleus, however, has 2 protons and 2 neutrons. That has quite a lot of mass compared with beta and gamma. So that's going to be a kind of big particle. An electron is a small particle, and then gamma, that's just a wave. So ionizing power, that's the idea of if this thing hits into something, is it going to knock off an electron and cause it to turn into an ion? So an alpha particle is a really big particle with 2 protons and 2 neutrons. So if it hits an atom, it's highly likely to knock off an electron to cause it to turn into an ion or to ionize it, because it's going to be really easy for it to bump into other atoms when it's so big. Whereas a beta particle, which is an electron, which has a very small mass and a high speed, that's moderately likely to bump into and ionize another particle. Gamma rays, however, is a high-speed electromagnetic wave with no mass. So that is going to easily pass through materials without hitting any of the particles or atoms in there. It's unlikely to ionize them. So alpha has the strongest ionizing power and gamma has the weakest. Now, penetrating power is talking about how far through a material can it get. So alpha, those big particles that are highly ionizing, they're very likely to hit into the atoms or the particles in a material because they're so big. So they're likely not going to get very far through the material before they've already hit something and ionized it. Gamma, on the other hand, is unlikely to hit or bump into and ionize other particles. So it's going to be able to get quite far through a material before it hits something and ionizes it. Beta is somewhere in the middle. So because of that, an alpha particle or alpha radiation can be blocked by just a sheet of fabric. That's all it needs to block that radiation. Beta can be blocked by a sheet of aluminum, and gamma can be blocked by a sheet of lead. So we have a much denser material there that gamma can be blocked by, compared with alpha that can just be blocked by a thin sheet of fabric. So when you're answering these questions, you just need to look at the type of radiation we have in question, and then use this table and your knowledge to answer the questions. So we'll do one together. This one is about a radioactive sample emitting alpha radiation. First question is, what is alpha radiation made up of? We know alpha radiation is a helium nucleus. It's made up of 2 protons and 2 neutrons. How strong is the ionizing power of this radiation? We know that alpha is strongly ionizing because they're these big particles that are very likely to knock off an electron if they hit into another particle. So strongly ionizing. What about penetrating? We know that they're weakly penetrating because they're so ionizing, they're likely to hit into something before they get very far through the material. So they're weakly penetrating. Which of the following best explains why? We know that we have large mass particles that are going to be slow moving. So here in answer C, it says we have particles with a large mass that are slow moving. They're highly likely to bump into and ionize other particles when traveling through a material. And that explains why they're not very penetrating, because they're going to hit into particles very soon into the material, but they are strongly ionizing because they're very likely to knock off an electron and ionize a particle when they come into contact. So we're going to say C for this one. Last question here is asking which of the following materials will be able to block alpha radiation. Now we know that alpha radiation can be blocked by simply a sheet of fabric. So we're going to say yes, it can be blocked by a sheet of fabric. Aluminum and lead are both harder to get through than fabric. So if alpha is blocked by fabric, it's definitely going to be blocked by aluminum and lead. So alpha is going to be blocked by all of these. Beta is only blocked by aluminum and lead, but can get through fabric. And gamma is blocked by lead, but can get through fabric and aluminum. So we can see this skill is really an introduction to what alpha, beta, and gamma are. It's all about thinking about the size and speed of those different types of radiation. Alpha has a large mass and therefore a low speed. Beta has a low mass and a high speed. And gamma has no mass and a high speed. And we can use those ideas to explain the ionizing power and penetrating power of our different types of radiation.